something malicious. So these are, that's another problem that I think will get more attention in the future. There's a lot of timing-based attacks where, say for instance, you're wgetting a file from the server, and it subsequently gets another file on that server, and the JavaScript itself says, you know, there's a 2-second period between each request. If you request it at 1 second period, the server can deny your request. The client can also use timing within the JavaScript so that if you don't respect the timing loops, then it will decode incorrectly. And finally, they can introduce infinite loops so that it never finishes evaluating in the case that it detects an incorrect version. Or, you know, these are ways to prevent us from finding what's actually there. So the final technique of preventing detection is actually using browser plugins and other techniques that can be used to load JavaScript. In the case of SWF files, they actually pass it back to the browser, and the browser will execute the JavaScript. In the case of PDF files, it contains its own JavaScript engine, which Adobe has released on the second link there. So a lot of improved obfuscation PDF files this year that I've seen also. We've talked about what the attacker's goal is. We're going to talk about what's available to a defender. So you could open the script in a browser, modify it, replace things, and print out the contents of the decoded what would be decoded. This is really not an effective technique anymore because too many scripts are using basically checks against the content. So you could take an MD5 sum of the content, compare it against a predefined value, and then determine if it has been modified. So you can get around this by using either an actual interpreter, which is SpiderMonkey, or using various debuggers, which execute in the context of the browser. So you don't actually modify the scripts. So this is kind of important to do. And then finally, you could also, there's several projects that have modified the JavaScript engine itself to extract information and variables. So these are some implementations similar to JSONPack, and they're slightly different in that my main goal is to make it quick and also to make it very lightweight. In the case of WebAwet, it actually uses a real browser, and that wouldn't be effective if you're trying to do it against every URL on a corporate network. So definitely check these out. So here are a variety of different types of decoding techniques that you could take. In the case of very simple scripts, you could just write your own decoder, translate, and figure that out that way. But once you get to the dynamic versions of those, they use the environment variables, they use HTML, they use the PDF format, a variety of these different things. So, and then finally, the most difficult, using server-side defenses and determining the versions you're running, and tracking your IP address. Basically, in the most difficult case, the best thing for you to do is actually visit it in a virtual machine, or visit it like an actual user would. So there's really two different solutions here. You could go after the full environment, put all of your tools to hook the browser, or you could do it strictly on the network side and watch passively as these scripts go by, so that you don't have to worry about these detection and difficult problems. So the source code is based upon SpiderMonkey and Python. The Python controls the SpiderMonkey program, which is the JavaScript interpreter. And this is the source code that I've basically released, and it basically has a JavaScript part which defines the environment. It set up all the hooks, and there's also a file which does the post-processing and part of the detection. What this does is, after the script executes, it will look through the current defined variables and look for shellcode and URLs that were defined in any variables. And the Python part of this is the detection library based upon Yara signatures, and also PDF, SWF, JavaScript decoding, and the main engine itself. So the first main new feature is the network decoding. You can pass either a network interface or a PCAP file, and the preferred technique is a PCAP file, because you don't have to run as root, and I think a lot of the benefit of the active mode is you can fetch any decoded URLs. And for instance, if it was shellcode and your actual browser didn't download the shellcode because it wasn't vulnerable, then this will go and download the shellcode or any other discovered URLs. So in that case, you can get the best of both worlds. You can also process scripts or files that you have locally with this. So a couple challenges I tried to solve when using the network version. Fragmentation with IP packets, and also TCP reassembly, and pipeline request, where there's multiple get or post requests in the same packet or in the same stream. And additionally, processing of gzip and chunked encoding. I didn't do anything for SSL. And then after we extract all these streams, we still have to do the JavaScript decoding. So the pre.js file is largely responsible for this. And additionally, you could, I do recommend modifying SpiderMonkey to take advantage of an eval hook. So to enumerate the environment of a real browser or the PDF engine, I use everything is treated as an object, so you can go through every every variable of that enumerated variable of that object using this type of loop, and then print out that information whenever you need it. So in this way, we can try and recreate the browser's environment as realistically as possible. And then in JavaScript, you can reassign the variables for functions. So if we take a variable function name and set it to our, we take a copy of it, then define it as a new function to execute the old function and do additional work, such as print out the contents of the obfuscated code, then we can get what we need. So there have been a lot of new hooked functions that are necessary to decode these things, and several of them are time-based. So set interval is one that I'll have an example with later. And additionally, you can do this with PDFs. Dieter Stevens has created a tool where you can just pass a file on the command line and insert JavaScript into a PDF file. And then you can profile it this way and figure out what's defined in the current environment and what they contain. So the other feature of JSUnpack is the rules language. This processes all decoded content. So if a hook applies to something, then we can define a rule that looks for any of the decoded data. In this case, this is a newer media.newPlayer vulnerability for PDF files. And there's, at the top of this Yara rule in bold, you'll see decoded PDF, and there's another keyword called decoded only. This is the rule language, which basically does what it says and allows you to put filters on the rule to say that this only applies to decoded content and not to regular HTML. So there's another type of rule that is necessary to detect these things, and that's a dynamic rule. And this is JavaScript. And basically, we're creating the object which will execute once the JavaScript actually executes. So both of these are necessary because if our script contains an error, we still want to process the static content and run the Yara rule. But if the Yara rule, if the attacker assigns the media to a variable, then our static rule will never detect it. So there's an output directory with JSUnpack, and it creates various types of files. Whenever it decodes something, it'll create it according to that name. In the post-processing, when it decodes shellcode, it'll create it of that name. And with the -s option, you can save all the streams and the dgzipped and dechunked content, and those get saved as separate names. Whenever the shellcode matches a URL within the packet capture, that's a special case where you know that the client who downloaded it was actually exploited successfully. So in that case, you can determine, you have a real incident here. Malicious code was installed. And then there's various other debugging and